Hi everyone. So this is going to be an ed puzzle on me reviewing with you the homework from last night, which was Newton's Law of Inertia, guided reading chapter 3. So you should have gone to chapter 3, read these sections in order to solve for the answers. So number 1 says, what was one of Galileo's great contributions to physics? And so in terms of motion. And so Galileo said that a force was not required in order to maintain motion of an object. It was only when friction was present that a force is required in order to keep that object in motion. And so that was his great contribution. So number 2, a force is any blank or blank. So push or pull. So remember that little kindergartner to describe forces. We're going to push them or pull their arm, right? So a force is a push or a pull. Number 3, what is friction and how does it act? So remember that friction is a frictional force, and so it's always acting opposite to your motion. And so it depends on the material that that object in motion is in contact with, and it also depends on the normal force, which we're going to learn more about later on. But basically the weight of the object. So more weight, more friction. More rough of a surface that that object comes into contact with, more friction. All right, so number 4, the drawings below describe each type of slope that describes the slope's effect on speed. So we see a negative slope here, but it's pretty steep. And so what's going to happen to that ball is that it's going to accelerate down that ramp. And so a positive slope for the second one. And so the slope of that ball, the ball is going to decelerate due to the slope of the ramp. So even though its motion is kind of shown in the upward direction, we all know that gravity is going to basically play an effect into this. And so it's going to cause it to decelerate and eventually start rolling down the opposite way. And then on the third image, okay, there is no slope. Okay, so if this object is not being affected by any type of friction, then this object is just going to continue on moving. But if friction is present, then we know that it's going to slow down. Okay, so this is no slope, and so it's not being affected by the slope as much, but gravity is still playing an effect by giving it weight. So number 5, based on his experiments with rolling balls, Galileo was able to conclude that when friction is present, a force is needed to keep an object moving. So only when friction is present is a force needed in order to keep that object moving. If there are no frictional forces present, then that object is just going to continue on moving indefinitely. All right, so number 6, describe the property of inertia in your own words. So it's kind of in your own words, but to kind of give you a definition, inertia is the it's a property of matter, and so it's the resistance to change your state of motion. So whether that means that you're at rest, then you want to stay at rest. If you're in motion, then you want to stay in motion. And so if you needed to change your state of motion, inertia is going to play an effect, because if you have more mass, then you have more inertia. If you have less mass, then you have less inertia. And so again, inertia, that resistance to change your state of motion. Okay, so again, a more massed object, there's going to be more of a resistance to change your state of motion, and then vice versa. All right, so number 7, what is another name for Newton's first law of motion? The law of inertia. So Newton's law of inertia. Number 8, state Newton's first law of motion. So Newton's first law of motion says that for an object at rest is going to stay at rest, and an object in motion is going to stay in motion until acted upon by a non-zero net force. So number 9, once an object is moving in a force-free environment, for how long will it move in a straight line? Indefinitely. So what we mean by a force-free environment is that there's no frictional forces affecting the motion of that ball or the motion of that object. And so it's just going to continue on indefinitely. So number 10, highlight the letter of each sentence that is true about the mass of an object. And so the amount of inertia on an object depends on its mass. And so, yep, so inertia is a property of matter. And so again, matter, if you take up space, if you have mass, then you matter, right? And so A, the amount of inertia an object has depends on its mass. Let's look at the other 3. The more mass an object has, the greater its inertia. That is also true. Volume and mass are the quantity. Nope. That sentence doesn't even really make sense. So nope, that's not it. And mass is usually measured in kilograms. So yes, for these next couple of units coming up, mass is measured in kilograms. All right, so number 11, which item below has more mass? Picture shows a pillow and a battery. And so more mass, that's going to be the battery, right? So the battery is going to have more mass than the pillow, which has more volume, the pillow, because it takes up more space. And which has greater inertia? So again, inertia is a property of matter, so it depends on how much mass you have. And so because that battery has more mass than the pillow, it's going to have more inertia. So again, that more resistance to change the state of motion. So number 12, blank is the quantity of matter in an object. So that's going to be mass. Blank is the force of gravity on an object. That will be the object's weight. Okay, so we were learning more about that yesterday, that weight is dependent upon the gravitational attraction of the object and the mass of the object. All right, so number 14, explain how a bird sitting on a tree can drop down vertically and grab a worm that is crawling on the ground when the earth rotates at 30 kilometers per second. So again, that motion is all relative to the observer. Okay, so there's an inside observer or an inside passenger and then an outside observer. And so because we are in the motion of the earth, okay, it feels that we aren't moving at all because again, motion is all relative. So we are inside the frame of reference or inside that motion. So again, think about it as if you were on a plane, right? It doesn't really feel like that plane is moving at all, but really that plane is moving at like 400 miles per hour. I think it's something like that. It could even be higher than that. Okay. And so again, all relative to the observer, right? If you are on the ground looking up at the plane, then you're going to see that the motion is changing. Right, you're going to see that the motion is moving across the sky. But because you're in the plane, again, you have a different frame of reference or a reference frame. And so it's going to affect how you describe that motion. All right, so number 15, a girl is sitting on a bus that is traveling at 30 kilometers per hour. She's throwing her tennis ball gently into the air and catching it. So highlight the letter of each statement that is true. So the tennis ball is moving faster than the girl riding on the bus. Nope, they're in the same system, and so that means that they're going to be all affected by the motion of the bus. And so it's not A. Let's look at B. So B, the tennis ball is behaving as if the bus were at rest. That is true. So if that bus is moving in a constant speed in a straight line, then that tennis ball is going to behave as if it is just at rest. And C, the inertia of the tennis ball changes when it is thrown. So remember that inertia is dependent upon your mass. It's a property of matter. And so the mass isn't changing as that ball is thrown up into the air. So it's not C, the inertia won't change. D, gravity affects only the vertical motion of this tennis ball. That is true. And so gravity is going to affect the vertical motion. So as you throw it upward, we know that that ball is going to slow down and then come back down. So gravity is absolutely going to play an effect on the vertical motion. It's also going to give that ball that has mass some weight. Okay, so I would say that it's A and D. All right, so please feel free to email me if you have any questions, and have a great day, everybody.